Hi everyone, welcome to the third chapter of ZW3D Get Started training series. In this video, we will talk about solid modeling. In this chapter, I will introduce the commonly used commands and the key differences between ZW3D and SolidWorks. Without further ado, let's get started. Firstly, in ZW3D, the module is named shape instead of a feature in SolidWorks. That's a slight difference. And if we look at the panels under it, you may notice that in ZW3D, it hasn't got extrude cut, revolve cut, sweep cut, and etc. The reason is ZW3D integrates the Boolean operations in the same command, which allow users to complete multitasks in one command. For instance, when you use Boolean add, you get the same effect as you check on the merge result option in SolidWorks extrude. And when you use Boolean remove, you get the same effect as extrude cut in SolidWorks. The next point, which new customer always ask, is about how to extrude contour rather than the whole sketch. As you can see, by default, it will automatically identify and extrude the largest outline of the sketch and build a solid. While in SolidWorks, you may need to click 2 times for the same purpose. And if you want to extrude a contour, you can switch on the little command in the Pick toolbar. And now you can extrude any region you need. Moreover, in ZW3D, you can also extrude the sketch as thin feature like SolidWorks. Just use Thicken option in the Offset drop-down menu, define the value, and that's it. Now it will expand the extrude area, and also you can define the inner offset and also the outside offset to make it a hollow shape. Another unique point is, in ZW3D, the extrude command works for both solid and surface, instead of having 2 sets of separated commands in SolidWorks. For open profile, it will automatically extrude as a surface. As for closed profile, you will get solid by default, while you can switch to surface result by cape option. And other commands such as revolve, sweep, and loft follow the same logic. Okay, that's all the points you need to know about extrude. Next, let's talk about revolve, which is used for rotary body modeling. The logic is mostly the same as SolidWorks. You draw a sketch and you revolve the sketch by the X, Y, or Z axis. Or you can use the sketch line as the axis, which is totally the same. But in some other cases, you need to revolve the sketch by an axis which is away from the mentioned axis. In SolidWorks, you might just draw a center line and use it afterwards. But in ZW3D, that's a little different. When you try to do the same, and then you exit the sketch, you don't see the center line. So you actually need to do one more step to do it right. We just right-click on the axis and switch to external axis, by which you can see the color is changed from gray to yellow. Now you're able to revolve based on it. The next command I'm going to show you is the sweep. There are 5 sweep commands for different scenarios, but in 90% cases, we just need sweep and the sweep road. For sweep command, the workflow is totally the same as SolidWorks. You select the profile, and then you select the path, and then you can get the shape you want. And if you want to combine the tangent faces, just remember to check the Merge Tangent Face option. And for road sweep, is actually one of our highlight features, which able to quickly create a solid pipe or hollow pipe. Now allow me to quickly create a path. We just create a random one to save time. And now you can see by sweep rod, we can easily get a pipe. And one nice thing is you can add the fillet automatically to the corner. Additionally, you can make it a solid pipe or hollow pipe, as we mentioned previously. Now we make it a hollow pipe. Okay. You can see it's much easier and convenient than SolidWorks. The next point I'd like to show you is loft. Similar to sweep, we divide it into 3 commands based on how many drive curves you are going to use. 0, 1, and 2. Now let me show you the typical loft command with 1 drive curve. Select the drive curve first, then select the first profile. Before you select the second, please remember to add the first profile into list. That's a unique behavior you need to pay attention to, or you will get a wrong result. And you can manually define the start point of each profile to better control the shape. The next command is fillet. The workflow is the same, while ZW3D has more efficient selection methods. You can either pick a single edge, or you can press Shift from your keyboard for chain selection. Besides, you can use window selection, just as you did in ZWCAT or other CAT system, to quickly fillet the area you want. Now you can see we get the fillet in also the back surface. And another cool feature I'd like to show you is face fillet, which applies to multi-scenarios. Firstly, you can use it to change a chamfer to fillet, which happens a lot in real design work. Just select two support faces and then the faces to be tangent. Now you can get the result. And secondly, you can use it to quickly create a complete fillet to a face. The workflow is the same. You just select the support faces and then the tangent face. You easily get a complete fillet. And then next, I'll introduce the hole command, which is indispensable in mechanical design. The only difference between ZW3D and SolidWorks is how to position the hole. In ZW3D, it got a nice feature, is to snap the special point automatically, such as the center of the cylindrical face. And then we can change the size and the depth, and that's it. But if it's not the special points, you can draw the sketch to create the locating points first before making the hole. For instance, here we create several points and add the necessary dimensions and constraints, which I'll skip to save time. Then we can exit the sketch, call out the hole command, and use the sketch points option in the right menu. Then we can get moldy holes. And also, you can call out the hole command first, and then use the sketch to quickly create the hole points. Just like previously, we create several holes. And if you pay attention, you may find we also have different hole types: simple hole, clearance hole, and threaded hole. And the user always asks is about the clearance hole, which is defined by the size of the bolt. Here we can also choose countersink or counterbore. And here we use the M20 bolt, and we use close fit. But sometimes users always think the diameter is not the way they want. In this case, we have custom. You can customize how many clearance you want between the bolt and the hole. For example, here we make it bigger by 2 millimeter. The next command I'm going to show you is flag external thread, which also called cosmetic thread. In ZW3D, it's quite easy. We just select the face we want to add the thread to. And it also supports to select both sides. And then it can identify the original size. And also you can change it. And also the length type is supported to change. And even you can add the end chamfer to the thread. The next command I'd like to show you is wrap. In ZW3D, it's called wrap to face, which can be used to create slot and cam. Now let me show you how to create such a slot in ZW3D. Firstly, we can create an unfold plane. We use this command, unfold to plane. We select the surface and a point as a locating point. Okay, then we get a planar face. And next, we create a sketch based on the planar face. In this case, we'd like to create a shape to follow the original boundary, so we can use the offset command. And here we offset 2 times. And then we can draw a line to close the area. Okay, and then we exit the sketch and we do the extrude. And the value we give it 5. And here you can see actually it make a surface because we remember the last option. So we switch to solid. And now we are able to use the wrap to face command. We use the third type. All we have to do is to select the geometry. So here please remember to select the whole shape. And then we select unfold plane. Okay, now we get the result. It's quite convenient. And another typical case is to wrap your company logo to the surface. Now let me show you how to do it. First of all, we make another datum plane. Okay, and then we create a sketch and draw our logo. For example, here we just draw ZW as the example. And we can make a double line text. And we can change it a little smaller, and also we can add some gaps between each letter. Okay, now we exit the sketch. And here we have a command called inlay, which is dedicated for such purpose. We select the face to be wrapped, and also the geometry. It can be text, and also it can be a closed shape. And this is the offset value. We make the 2, and then we need to define the projection direction. So we need to project the text to the Y direction, right? So we choose the Y direction. And another direction we need to define is the inlay direction. By default, it will inlay based on the face normal direction. So here we can make it by default and check the result. Okay, so we change our view angle to see if that's the result that we need. Now you can see it will strictly follow the face normal direction. Okay, so let's check what will happen if we choose a certain direction. For example, in this case, we choose the negative Y. Now we check again. So you may find all the text will wrapped into the Y direction. It's not the face normal. And also we can make inboss or deboss based on the value. Negative value means deboss. And the next command I'd like to show you is split face. In some cases, we need to split a whole face into several pieces to make different dimensions or annotations. For example, here we have a shaft. And now let's see how to make the split. First of all, we draw a line. And then we can use a surface command. It's called split by curve. We can choose the face to be split and the curve. And then we need to define the direction to split. In this case, we need to define to Y direction and both negative Y and positive Y. Now you can see we get the result. we have two faces now. And the next command I'd like to show you is helix. It's similar as SolidWorks, but much more powerful. It can make so many different types of spring, such as the one I'm showing now. In ZW3D, it's quite easy to make this, while in SolidWorks, it's not so easy. You have to do several steps to make the same result. Now let me show you how to do it in ZW3D. We call out the helix command. We use a second type. We select the path, and then we define the value. And then the length, we have different method to define it. In this case, we choose pitch and revolution. Pitch and revolution, we can make it 12 or 10. And also you can make it revolve clockwise or anti-clockwise. And then you can combine the sweep the road to make a spring. It's quite easy and very convenient comparing to SolidWorks. And then previously we have mentioned how to use the basic shape and engineering feature. And here I'd like to show you pattern and mirror. You can see we have a pattern geometry and pattern features, similar as mirror. So you have to understand what is geometry and what is feature. Geometry means a face or a whole solid. For example, here we use the rectangle pattern and we pattern the whole shape. We just define the distance and the numbers of the pattern. Okay, now we get the result. And now let's check out what is a feature. Here we have a hole. And in this case, we need to use pattern feature. We select the whole feature. And as the same, we define the direction, the spacing, and also the number. Okay, now we get the pattern the hole. Now let's check if I use pattern geometry to pattern the hole, what will happen? Here we choose the whole face. You think you choose the whole feature, but actually it's just select a surface. Now we do the same, spacing and the number. You can see actually it's just pattern two surfaces instead of a holes. So that's the difference between geometry pattern and feature pattern. The mirror is also the same logic. Just now we spent 20 minutes to introduce how to design by ourselves. But from time to time, we have to receive the models from our suppliers and edit it. Now let's see how to do it in ZW3D. Now we open a step. Okay, now you can see we get a static shape without any modeling history. So we can view it, and also we can annotate, or we can inquire it, measure it. That's no problem at all. And also we can build more features based on that. For example, here I draw a circle, and then I extrude to cut the middle area of the shape. Okay, now I get the result. There's no problem to build more features based on that. But in most cases, we have to modify something or we have to delete something. So in ZW3D, we have a very powerful direct editing features. For example, here we can use the simplify feature to quickly delete a slot. Remember, we used the window pick. And now we select all the faces inside the slot and we can delete it. It's very powerful. And we can do the same for the other slots. And also in ZW3D, it supports to modify the radius of the hole. For example, here we have a hole which is 4 for the radius, and now we can edit it into 3. And please remember to press Shift to select the whole surfaces. Do not miss anyone. Yeah, just like this. And also for the fillet, we can also use the modify fillet command to change to a different value. In the end of the video, I'd like to share with you one small tips which users always ask. Is it how to select the feature in the graphic area and then modify it quickly? For example, here we have a cylinder. I don't know how to redefine it. So here I'm share with you 2 different methods. The first one is right click and select scroll to tree. Then you can find the feature and redefine the sizes. The second method I'm going to show you is turn off the direct edit picking. After that, you will check what will happen when you right click the surface. Now you can see the command is totally different. You can directly redefine the cylinder without any hesitation. The reason is very simple, because under the direct editing picking mode, you can quickly pick like an edge, and then you can call out the fillet very quickly. It's very convenient. And also, similarly, if you double click on a planar surface, it will call out the face offset command. Then you can edit very quickly. So it's really depend on how you are going to use and how you are going to design. Okay, that's all for the videos. Thank you for watching.